Thank you. Here we go. Thank you. Wow. Well, I guess I don't have to tell you what I did. I never thought I'd be standing here doing this. Just checking to see that that door swung out, actually. They wanted to make a slider. I said, nah, it won't work. Anyway, in retirement, though, because my background is engineering, and I also have a very deep love for photography, in my retirement, am I over the line? No. Okay. Decided to embark on a project, or hoped to embark on a project to capture the reconstruction of the Sarah Mildred Long Bridge. You know, it was named after Sarah Mildred Long in 1987 when she retired, after she retired 50 years with the New Hampshire Main Bridge Authority. And for us locals, we always called it the Middle Bridge, or the Dime Bridge, right? How many remember putting a dime in the toll? But then in 1972, this bridge came along and the toll booth closed down. Not many here probably remember the shot was taken by me with my Kodak Instamatic camera in 1970 when I was an engineering student and would come home, and I was just absolutely fascinated by the construction of the high-level bridge. As you can see, they built it from both sides and it met in the middle. But I was extraordinarily fortunate with this gig. I was able to land a gig with Chinbro Corporation, who was the prime contractor for the Sarah Mildred Long reconstruction. And they wanted progress photographs every month of the project, and they wanted them from the air. And so that's what this talk will focus mainly on. Before embarking on that, I asked them, well, if I really need a plan, since I'm an engineer, I need to, something to look at. And so they provided me this plan that shows the overall scope of the project. In blue is the old roadway section. Here's the Port Authority in New Hampshire, Kittery over here. And in orange is their roadway or construction trestle, they called it, which was their temporary access out into the river channel for the construction of the new bridge. And then the center line of the new bridge sort of followed that trestle, picked up over here near Albacore Park and then over here in Kittery. So my mode of transportation for this adventure was the Robinson R-22 helicopter, the little blue helicopter, not the little red one. And I flew out of Sanford, Maine, York County helicopter. For 17 of the flights, I was in this rig, and then for 3 flights, I was in a little bit larger aircraft. It's a 2-seater, so there's not a lot of room. This is my legs here, just room for me and the gadget bag and the pilot, hopefully. So my first flight was in March and April, my first 2 flights, March and April of 2016. Actually, I was flying for Case Foundation, who was the prime subcontractor for Chinbro, doing the overwater foundations. And this is a shot, oops, of that work. We'll go back one more here. And they're actually drilling the shafts that make up the overwater foundation. There's 29 shafts that make up the overwater foundation system for the project. And you can see the shaft tops here on this image, and this is the actual railroad trestle that I mentioned that they would work off of for the entire project. This image here shows the actual drilling of one of those shafts. There's, as I said, 29 of them. They're 10 foot in diameter, and they get drilled 35 feet into bedrock at the river bottom. And then once the shaft is drilled out, these steel shaft liners are installed, and they're 100 feet long, again 10 feet in diameter, and they form the foundation. They'll get first reinforcing, will be lowered into each one, and then concrete is poured, and that ends up being the foundation basis for everything we drive on when we go over that bridge. The tower foundations were sort of interesting because there were 8 shafts that make up the anchoring of the tower, each tower, and then these precast concrete tubs were precast off-site, were brought in by barge and then lowered over the shaft caps And then when they're all 14 of them, all 9 tubs were put in place, they form this basically tub that you see here, which is 10 feet deep. And that makes the actual footing, foundation for the towers. And once they were dewatered, then reinforcing steel was installed in that 10-foot cavity. Embedments to anchor the towers were installed. And we'll see in a moment the placement of concrete. This is a view out the window of out the door of the helicopter. The only way to do photography in this method is you can't shoot through glass. And so the pilot told me, we have to take the door off. I said, really? And actually, it's a thrill. For the photographers in the crowd, you don't use lens hoods when you hit this, because it will, and one of the worst things they told me is to have anything come in contact with the tail rotor. It's a really bad day. So, while things were going on in the river, a lot was happening over at the Port Authority. Chinbro was precasting all of the tower segments. There's 84 segments that would make up the 4 towers, and they would do that in this jig right here, which is a Scandinavian design, and then these would end up going on barges and then being placed on the towers, and we'll see that in a moment. As I mentioned earlier, the placement of the concrete in the tower foundation was done overnight. It's mass concrete, and it creates heat when it cures. It's called heat of hydration, and so it's best to do it at night when the air temperature is cool. Here's concrete trucks dumping into a concrete pump, and that pump pumps it into the foundation. 1,500 yards would go in this night, and then they would take a second night and put another 1,500 yards of concrete in. So each foundation has 3,000 cubic yards of concrete that make up the tower footings. In, I think it was in September of 16, the old Sarah Long was closed. It was deemed unsafe for travel, and so the center span went up because river traffic has priority. And we can see here that the Kittery Towers have started, and the reinforcing on the Portsmouth side is well underway. And here I mentioned that the tower sections are on a barge. They'll get transferred and go up. We'll see that in a moment. Actually, because the roadway was closed, I was able to get up on the bridge, the old bridge deck, and photograph this morning of the 5th block in the Kittery East Tower going in, KE5. Each of these blocks is 80 tons. And there's 21 of them per tower. For the tower ends up being 200 feet tall. They're anchored and cabled down through and into that foundation that we saw earlier.
Heck of a Lego build.
Yes, very much so. Shot from the air, looking down at the towers. Over in Portsmouth, they actually installed the stairway systems in each segment. So as the segments went on top of one another, you had access automatically. And then, of course, the void that's inside here will be where the counterweights will ride, and we'll see that later. So, big job in terms of the removal of the old bridge. The first order of business is to get the center span out. And this is an image from the air of the morning of the nighttime that they were going to float it out. It's tide dependent. And so I couldn't time my flight when they were going to take it out, actually. So they've already removed some of the roadway sections. In an image that's coming up, the ironworkers will be burning the steel away. But in order to pull this job off, they take this barge here, and you can actually see the tugs working. They're going to bring this barge underneath the span at low tide, and then wait for the tide to rise, and that was going to happen around midnight. And then once the bottom chord of this truss makes contact with the barge, let the tide continue to do its job, cut away the steel, and then float the section right out. And that again took place around midnight in October. Whoops, wrong button. The next order of business was to get those old counterweights down. They're concrete filled, there's the steel shell and a concrete filled, and they had saw cut them into 4 pieces when actually earlier, and to make it so that they'd be able to lift. I don't know what they weighed, but needless to say, it's that solid concrete. They were pretty heavy. So they all came down in 4 individual pieces. And then the next order of business, of course, is to take the tower down. This is a shot from the Kittery side. I made friends with some really fantastic folks over on Mendham Avenue in Kittery who basically said I could come onto their property and shoot all the any time, day or night. So that was great. In November, all that was left of that center span over at the Port Authority was the bottom chord, and you can actually see the railroad track here. All of the structural steel of the old bridge was brought to the Port Authority, disassembled, and then I think sent to Massachusetts for recycling. Of course, I mentioned the railroad track in the center span. We remember that the old bridge, the bottom section of the old bridge carried the railroad, and then there's the travel way up there. And that's the same design for the new bridge, but we'll talk more about that in a bit, and we'll talk about it right now. So this actually is a shot in November of 16, with the railroad deck well underway on the New Hampshire side. And you can see the disassembly of the old bridge there. Also, what's happening here is the arrival of the first pieces of the roadway deck. And these are balanced concrete segmental box girders right here. And this particular flight happened to be timed with one of the arrivals of one of those pieces on a multi-wheeled special transport. These were all fabricated in a fabrication plant in western Massachusetts and then trucked to New Hampshire. What's going to happen here is these pieces are going to be assembled onto a pier right here is ready for assembly. And this is an aerial shot a month later of that pier, and there's actually 3 segments here. There's a center segment and 2 on each side. And they build this in a method called balanced cantilevered construction. And so they're building out from that center equally on either side as they progress. And so oh yeah.
I gotcha.
Okay. Ultimately, what you get is...
Yeah.
There you go. How'd you do that so fast? That's pretty cool. Oh, you work here, right?
I've done that before.
What button did I push? This bottom one here?
Yeah, it must have been.
Okay. Anyway, so you end up with this basically... See, I didn't want to do that either. Got all shook up. This teeter-totter here with... balanced cantilevered form of construction is what it was. It's pretty revolutionary. And this is a shot of that same construction happening over Market Street. I want to call attention to a couple things here. So it's supported on one end here, and it goes both ways, and then it's supported here, and it's going both ways. But over here is the old approach, the old structural steel approach, the 1940s engineering, where we have structural steel on multiple piers. There's 8 piers that support this old structure in the same distance that we support the new structure with 2. And that's pretty cool, I think. And we really see that when we come down Market Street now. The visual image is not cluttered with all of these concrete piers, and especially the one in the median. So, it just shows the advancement in engineering and construction over the years. Finally, after they come together, as I said, all of these are precast except for that center keystone piece, which is actually cast in place. In the meantime, on the other side, we're taking apart the old roadway deck on the Kittery side. We're going to see an image of that truss being floated out here in a moment. But first, the arrival of the counterweight boxes. I show this image because it gives us a perspective of the size of these. This is a box laying flat on a flatbed that came down from Casco-based steel, and a worker here. So we can see its relative size when it's on land, but when it's being lifted into place, this is the concrete box. Now there's a box for each tower, And this is where the counterweights are placed. Each box ultimately will have 1 million pounds of counterweight in them. And so this is lowered obviously empty and then later filled, and I think that's why the windows are there, so you can pile steel bars. I mentioned earlier that the section of the old bridge was floated out. Again, same principle as the center span. Bring the barge in at low tide. The tide comes in, raises the bridge up off its points, and then it floats over to the Portsmouth for disassembly. January of 2017 was a milestone day here. This is actually the 84th segment of 84 tower blocks being installed on the Kittery East Tower. So this was early one January morning, so sort of a topping off of the tower. They're 200 feet up, bringing this 80-ton piece into position. Also in January was a milestone, the arrival of the first two pieces of the center span. They were also manufactured in Casco Bay steel up in South Portland. And ultimately, the center span would comprise 14 main pieces. Now, up until this point, the entire bridge, the approach, and the towers is, of course, concrete. Center span is different. It's structural steel, but for the driving surface because of weight. But these pieces are, I think, around 20 feet deep. We'll see some images later. 15 to 20 feet deep, and there'll be 14 of them that will be taken from this barge and installed on this barge here, and we'll see that as we go forward. I show this image for a couple of reasons. One, to just show you a visual difference between the foundation of the Kittery Old Bridge Tower, is that right there, versus the size of the foundation of the new bridge towers. This following video, I'm standing on shore over here looking at this element, the foundation, the footing, and these towers will show up in the background. They'll look like it's real close, but you can see it's actually the opposite side of the river. And so this is that tower section, the tower foundation, covered in blasting mats, and it was pouring, absolutely pouring. The demolition contractor was responsible for removing all rubble they did this on every overwater pier. They kept it pretty quiet. They didn't let people know this was happening, kind of. What's that?
Do that again.
Can we? Actually, you can see the primer cord ignite right here. It's a flash of light. And you'll see also that when they do shots like this, it's a progression. There's timed fuses on these, and probably it's electronics now, and you'll see it blows from one side to the other. It's not all one big explosion, right? It's a timed explosion. 10 seconds? You can see it was noon. You can hear it was noon, right? The demo contractor was responsible for moving all rubble from the river bottom down to mudline, and they spent months, weeks, a couple of months doing so. Actually, that's them doing it right there. There's a long-armed excavator. I mean, it's almost by feel. The operator is picking away. He's got a thumbed bucket, and so in keeping with the theme of water, I thought I'd show this. You haven't seen much water lately, right? This just is it was a gorgeous flight in May, and it just shows the shipping channel, the memorial, Fort Tree and Pierce Island, Newcastle, and there's Isles of Shoals right there. Wow. Whaleback is right, I think that's the lighthouse, I think right there. So, and the Hotel Wentworth, I think you can see, yeah, right there. Yep. So, so back to the 14 pieces of center span. This is piece number 4 being offloaded from this barge. It will go over here. And it's beginning to look a little bit like something, but not quite. We'll see in a minute. Just an overall view of what's happening at this point. The railroad deck on the main side is well along. The roadway deck on the Portsmouth, New Hampshire side is well along. This particular flight was interesting. The center span is really taking shape, and now all of the main pieces on the top that make up the roadway deck are installed. This particular day, I happened to look at I didn't actually know this when I was flying. This is a lifting girder, a plate girder that's similar to this lifting girder that's already in place. You can see the worker right here, so you can see the size of this. This is going to get installed right on this end of the span. And this is what does the heavy lifting. The cables, the lifting cables, will connect to the lifting girder right here and on all 4 corners. And so they're getting ready to lift this up and put it over there. And speaking of lifting and doing the heavy lifting, this is an aerial of the counterweight sheaves or pulleys that are what we see at the top of the towers. These were manufactured, fabricated in Louisiana and then barged to the project. And they're 20 foot in diameter, and they weigh 100 tons apiece. And they go, as we know now, up here between what we call the sheave walls, and they'll set right here. And this image is the first sheave being raised up. This is the maximum lift crane, a 300-ton crane that Chinbro actually bought specific for this job. And it's going to be placed on the Portsmouth West Tower. And that's what, so they're guiding 100 tons, and they're going to set down on these anchor bolts from that is going to go right into there. There's a similar shot in the Kittery side a few weeks later. This is the Kittery East sheave going into place. This guy actually isn't waving at me. He's talking, he's talking to the crane operator but on his walkie-talkie. And again, it sets down on these bearing points.
Don't pinch your fingers.
Right, right. Yeah, it's amazing. It's just amazing. So one of the main goals of, there were several main goals of this project, but one real main goal was to get this channel more shipping friendly. This is an image of the Tacoma bulk hauling ship, probably hauling gypsum, through the old Saralong. And you can see there's not much clearance. The tug, there's a stern of a tug there, there's another tug right there. The tugs cannot guide the ship through the opening. They have to break free, go ahead of the ship, and then pick the ship up as it comes through. So I guess they achieved one of their goals here. This is a shot taken from the high level, and there's plenty of room. It's a 300-foot span now, and the tugs can accompany the ship through. This particular day, it was an interesting operation going on out of this basket being supported by this crane. A lot of people wondered what gave with the paint job, because some of the blocks were put up and there's no artistic paint. Well, of course, the blocks were cast year-round, and you can't paint in the winter. And so they were forced to do everything from a basket. And these fellows actually are doing a scribe line before they would come back and paint the towers that didn't get painted. This particular shot, the road approach on the New Hampshire side is now drivable. And the Kittery side is almost drivable. It's about half the distance. The approach structure on the main side is about half as long as it is on the Kittery side. On the New Hampshire side, sorry. The center span is beginning to look more like something. This is a month before it's going to get floated into place. The reinforcing steel is in place. The railroad track is in place in the center of the span, and we'll talk a little bit more about that in a couple of slides. Before that can be done, though, the counterweight cables had to be installed, and these 2.5-inch diameter cables. This end here will attach to the bridge, and this end here goes up over the sheaves, and goes down and connects to the counterweight basket that we saw earlier. And this gentleman here is making sure that they lay perfectly over the grooves in the sheave. All ready for this day, which was float-in day, which was October 18th, 2017. Actually, it was 1 year and 4 days from the day that they floated out the old span. And this was, anybody with a white hat had to be on project this day, I'll tell you. So it was a pretty big deal. As far as I know, I was the only photographer covering this from the air. The method here is this brown barge is spiked to the river bottom. This gray barge is going to, the brown barge is going to be used as a guide along this edge, and the gray barge is going to push the center span barge, which has a center span on it, into position. And with the work of the tugs, and this shows that operation. These guys are working pretty hard. Now we circled quite some time, and I don't think it ever moved. So I didn't want to run out of gas, so we had to abandon it. But it finally, and keep in mind, this is 300 feet long, and as it sits there, it weighs 3 million pounds, and there's about 3 inches of clearance on each side. And so they didn't pay attention to us circling. They decided to take their time.
Other things to
Yeah. Actually, here's a good, here are the counterweight sheaves. You can see the cables coming down. And I'm going to speak about pulleys in another couple slides. And actually, these are the 2 pulleys I'll be referencing right there. And we'll talk about that in a minute. So just the opposite of floating out a center span, floating in the center span takes place at high tide. And then as the tide leaves and the span settles down onto its bearing points, and you can see the barge is gone. They had 10 days to get this thing operational. But before that, they needed to add some weight, because I mentioned the center span as it floated in was 3 million pounds, and we have 4 counterweights at 1 million each. So we're missing 1 million. So we're gonna add some of that or all of that by casting or placing the concrete deck. And that was done again over a night time. It took an entire night, and they worked from both sides. This shot is looking toward Portsmouth. You can see the concrete laying machine here and then over here, and it was all done by bucket. And so they bucketed all of the concrete. You can see the concrete falling out. So then, okay, so now it's operational, and that's good, but we still can't drive over it. We need pavement, and winter's coming. And paving, as you may know, is sort of temperature dependent. And this particular day, they got unbelievably lucky. This was November 15th, and it was an entire week of inclement weather, but for this day. And they were able to pave the entire New Hampshire side in one day. One morning, they got the base coat down, and in the afternoon, they were able to get the wearing course down. And in that last image, you could see all of the tractor-trailer trucks loaded with bituminous concrete or asphalt, waiting to get their load deposited here. A view from the operator's control house. There's a lot of cameras that monitor what's going on the bridge. The bridge is operated by a single operator, and this is the control panel that actually does the lifting. You can actually see the span is up here when this picture was taken. And how does it work? So it works by electric motors. There are 4 electric motors, 150 horsepower motors, 2 in each tower, and only 2 operate at a time, so they can alternate. And they go through gearboxes. No. They go through gearboxes and a drive shaft, and ultimately connect to this operating drum. You'll notice there's 2 sets of cables that come off the operating drum. One set of cable goes to the bottom of the weight basket. The other set of cables goes up and over those 2 pulleys that we saw in that aerial, those smaller pulleys, and goes down and connects to the top of the weight basket. And this is an image looking straight up the shaft. That's 1 million pounds staring at us right there. And these are the cables going up. So if I want the bridge to go up, I pull with those electric motors, I pull the weight basket down and the bridge goes up. And then when I want the bridge to go back down again, I pull on the weight basket, pull it up, and the bridge goes down. And this is a shot looking down at that weight basket. And these are the counterweight cables here, the 10 counterweight cables that we saw being installed earlier. And these are the operating cables. And that's how it runs. Piece of cake. And why did it take so long to open Chinbro? Oh, ooh, that's another. No. So, anyway, but it did finally on March 18th. This image here was architects rendering, bridge design, bridge architects rendering of what the bridge would look like. And interestingly enough, they did a pretty good job, I think. And we'll see that in a moment. I just wanted to call your attention to that for a future slide. I was able to be up on the Kittery East Tower during the first vehicle over. And this actually contained the retiring, I believe, New Hampshire bridge engineer after 30 years. He got to ride in the first truck over. And this is the first cyclist over. He actually, I think, came from Kittery, so this is his return trip. And actually, it is cycle friendly. You can cycle over it. So we've got the road open now. We've got to finish the railroad deck. We talked about the railroad underneath the approach structure. This is underneath the road deck here, and these guys are laying the track, getting ready for the first locomotive test. And this was on May 17th, 2018. And this is an interesting shot because it's something that we don't normally see, and I want to address why we don't see it here in a moment. This is the center span down at railroad level. This is the road up here. Okay, there's the operator's house right there. And so this is really unique because the track is in the center span. You probably have seen it, maybe not, but now you know that it's there. You see this, it's actually embedded into the road deck. And so it only has to lower for when a train comes over. And a train only comes over because this track goes to one place, the shipyard. And I'm told the only reason the shipyard uses this rail is to remove spent nuclear fuel. So when they refuel a sub, this is the way the fuel leaves the base over the bridge. Years gone by, this track system was much busier, but now it only goes to the base. So consequently, the bridge only has to go up for larger vessels. This is the train coming over. And I had mentioned that the view of the perspective that the bridge engineers and architects viewed what the bridge would look like. This is a shot, Maine DOT asked if I would try to get some shots after it all was done. So in keeping the theme of water, we got a few here at sunset, and of course for the photographers in the crowd, we know that the light, stay put, the light will change. This actually shows that the distance. So here is the railroad, and here is the roadway. Now if it had been like the old design where the railroad also was incorporated below the center span, you know, it would be down here, and you'd have very little vertical clearance for smaller vessels. Now there's 56 vertical feet of clearance for vessels other than the larger ocean-going vessels. So consequently, this span goes up 68% fewer times. Yeah, it's pretty good. I think the gates still, though, come down one at a time, though, right? So, this is a shot I took from Market Street, and with the towers lit, and I actually called the bridge operator and asked him if he'd turn on the lights for me. He said, well, you're not really supposed to. It was actually a woman. She said, you're not supposed to be taking pictures of the bridge. I said, well, I wish you'd told me 7,000 images ago. But anyway, so I hadn't, up until this point, I hadn't flown the final flight for Chinbro, and they're clamoring, and I explained that, oh yeah, I'm clamoring too, but when are you going to get the last piece of equipment out of there? And I really wanted a virgin project. I wanted no construction equipment, and so finally on June 15th, I happened to be sitting at my computer on the tugboat webcam, and there she was, being floated out finally, which paved the way for my final flight. on July 8th, 2018. This was the Sunday of the 4th of July week, and so we have a lot of folks escaping the state of Maine on using both bridges, and a lot of river traffic too, which made kind of an interesting subject. You can see all the cars heading south, and all the boat traffic. Now, oops, wrong button. I had called, we were going to fly in the evening, that's best lighting, and I had called the bridge operator at noon and told him who I was and what I was going to be up to around 5, and not to get too wigged out because we were going to be circling quite a bit. And then I said, you know, if I don't ask you this question, I'll regret it for the rest of my life, and I totally get it. You know, you've got a weekend, holiday traffic. If you can't do it, I totally understand, but would you raise it for me? And his response...
Oh, so it was you.
Right there. His response was 25, 50, or 100%, would you like? And what did you think how do you... So, it was me. This guy wasn't too pleased. And they all were looking for the boat, and I don't know whether they thought that was the boat. But it was me. And I gotta put a plug here. So this image is still for sale. This image is over at the Kittery Community Center on a 16 by 24 canvas. It's one of my 3 images that I submitted for a show over there when I first did this talk. And it's the only one that hasn't sold. So only $200 for the 16 by 24 piece of canvas. And this is the image. Had to get that in, right? So in keeping with water, this is one of my closing shots. This is sort of, I think this is neat with the water and the sort of the more graceful arches of what they could have done, you know, a lot worse of the design. I mean, I know the jury is out on whether you like it or not, but you know, it's not. And this is the railroad deck underneath. So. It wears on you. Oh,
I think of the bridge the same way now.
Yeah. So, thank you for your time.
Yeah.
Wow, 24 minutes.